This video demonstrates the use of IGW to create a hierarchical groundwater model in a real-time manner. A watershed with a large capacity pumping well is modeled at a coarse resolution. A monitoring well is placed near the pumping well to measure the drawdown due to the pumping. First, only one model is used to simulate this watershed. The monitoring well shows significant drawdown due to pumping. However, the distance between the pumping well and the monitoring well is smaller than the grid resolution of the regional model. To better resolve the dynamics near the well, a patch or child model is interactively added in the area of interest and simulated. The drawdown predicted by the child model is seen to be smaller than that predicted by the regional model. To further resolve the drawdown code near the pumping well, another patch is added within the existing patch. The drawdown curves from the three models of increasing resolution are compared. The steps to create the model are as follows. 1. Select the pre-made domain polygon to edit the aquifer properties. Go to the Flow Properties tab and check the Conductivity box and assign a constant K. In the Elevations tab, check the Top Elevation box, assign a constant top elevation, and uncheck Use as Starting Head. Next, check Bottom Elevation and assign a constant bottom elevation. In the Source and Sinks tab, go to the Prescribed Flux subtab, check Recharge, and assign a constant recharge. 2. Select the lake polygon in the top left portion of the model domain. In the Source and Sinks tab, go to the Head-Dependent Flux subtab, check Two-Way Head-Dependent Flux, and use the default values for lake stage, bottom elevation, and leakage. 3. Add a pumping well next to the lake by using the vertex coordinates input box at the bottom of the IGW main window. Edit in Attributes Explorer. Assign as a pumping well and select Transient. Open the Transient Options window. Uncheck Random Fluctuation and Periodic Fluctuation, then click Edit. Update the transient pumping data. Delete all of the time cells other than 0 and 180 days. Then use the Update, Delete, and Insert buttons to update the transient data so that there are prescribed pumping rates for each of the 4 pumping intervals, spanning from 0 to 3,650 days. Four. Add a monitoring well next to the pumping well by using the vertex coordinates input box. In Attributes Explorer, select the newly added well and select None for the source sink type. Then check the monitoring head and concentration box under Monitoring Well. 5. Discretize the model. 6. Open Attributes Explorer. In the bottom left window, check Head/Concentration under the monitoring well. Note the head hydrograph that opens as a result. 7. Run the model. Note the changing flow patterns in the plan view and the dynamic head hydrograph. 8. Stop the model. Create a patch or child model around the lake and pumping well using the Create Submodel icon. Create the submodel in the same fashion that one uses for creating polygons. Edit in Attributes Explorer. Select Model 2-1 and use the default grid size and default parent-to-child grid ratio. Note that the patch model grid size is half of the parent grid size. Go to the Down/Upscaling tab and ensure that the prescribed head boundary condition is selected under Downscaling from Parent. Upscaling from the child to parent model is also available, but not used in this example. 9. Discretize the model. Note the new child submodel window that appears. Open Attributes Explorer. In the bottom left window, check Head/Concentration under the monitoring well in the Model 2-1 window tree. This will open a new head hydrograph window for the submodel. 11. Run the model. Note the difference in the head hydrographs as the model proceeds. In particular, the drawdown simulated by the child model is less than that simulated by the parent model. Stop the model and add another patch within the existing patch. Use the default grid size of 50 meter by 50 meter for the newly created patch model, Model 2-1-1. 13. Discretize the model. Note the new sub-model window that appears. Display the head hydrograph for the sub-model. Run the model. Note the difference in the head hydrographs. The sub-model predicts a drawdown between that simulated in the parent model and the first child model.